Welcome to the handout number 4 video. In this video, we will walk through a few of the interest problems found on handout number 4. Let's get started with the first problem. The first question has to do with peppermint patty. Now, by the way, don't forget that when you finish your work, you'll need to submit a scan of your written work. So make sure that as you're watching this video, you're taking down good notes that you can have ready to scan to submit. This should be titled your last name, first name, and then handout 4, and it should be a single PDF file. I'm going to really recommend that you save a copy of your PDF on your computer and then upload that PDF to Blackboard. The first question says that Peppermint Patty took out a loan and we have a set interest rate and the entire balance. So that's going to be the interest together with the principal, right? How much she has to pay back, the entire balance is going to be both the interest and the principal, the amount she borrowed. So let's jump into this. We don't see anything about compounding. So this must be simple interest. So I'm going to use the formula interest amount equals principal times rate times time. I equals PRT. I could read from this question that the principal is how much she took out for the loan. That's the $4,500. Oh, and you know what? It looks like I wrote that wrong here. So $45,000, right? Peppermint Patty took out a loan for $45,000, and the interest rate, let me highlight that, was 10.3%. Let me give you a quick review. 10.3%, that means 10.3 per cent per 100. So if I divide 10.3 by 100, that's going to be the same thing as moving the decimal 2 places to the left. So it's 0.103. The interest rate is 0.103, or 103 thousandths. And if we read the next part of the problem, we see that she's going to pay the loan back at the end of 5 years with one payment. How much was that payment? One thing that we're going to do is imagine that the interest is not compounded. Really, in a loan like this, the interest would have been compounded if Peppermint wasn't making any payments. And what that means is that Peppermint would pay interest on the interest. Now, some of you enrolled in this class may be considering or already using student loans. There are times when your student loan goes into what we call deferment, or in other words, you don't have to make a payment on that loan because of different life circumstances. But most of the time, the interest continues to add up. There's another process we have for student loans, and that's a process where you might not be required to pay the full loan amount. They might set your loan amount, your repayment, based on your life circumstances, such as your current income, etc. But here's an interesting thing about that. Your loan continues to incur interest, and even though you're making a payment, if your payment is less than the interest, then what's happening is the interest is being added on to your loan, and your balance is growing rather than decreasing, because that interest itself is then charged interest and so on. So watch out. If you're going to use a student loan, make sure you are doing that thoughtfully, carefully, and pay attention to what your balance is going to be if you do defer the payments, or if you take more money out as a loan than what you needed. But anyhow, let's get back on topic with Peppermint. Peppermint took out a loan for $45,000, and we've got her interest rate and the amount of time, because we're looking in part A here, it says if she paid the loan back at the end of 5 years, how much was that repayment? If I do the simple interest equals PRT, this is going to give us an interest amount. And that interest amount is what I'm being asked for here in part B. And then part A is going to ask us to go back and look at how much would Peppermint pay back. To get how much Peppermint's going to pay, we'd have, and do you see I wrote that incorrectly again. I'm going to blame it on my old eyes. I was looking at that small print and misread the amount, but it's $45,000. And we're going to add to that whatever interest amount we got here. And that's going to give us the total that she would pay back. All right, that's a good warm-up. Let's move on to number 2. Number 2, Windy Day. Windy Day put her tax return money into a savings account for a rainy day. 5 years later, a tornado struck her home and she wants to withdraw that rainy day fund. We've got an interest rate and we're looking for how much money would she have at these different interest rate amounts. In each of these questions, we could see that the $3,450.23 is the principal. That's how much she's saving, how much she's depositing. And we could see that for all of the questions, it's 5 years later. So T is 5. And then what's going to change for A, B, and C is the interest rate. So let's start with this first example. We would simply put the principal 3,450.23 times 5 years times this interest rate of 0.078. And did you catch that, by the way? We've got 7.8%. What does percent mean? It's per 100. So that's the same thing as dividing by 100 is the same thing as moving the decimal 2 to the left. So we have 78 thousandths, or in other words, decimal point 0.078. You could put a 0 in front of the decimal or leave it. And when we do that multiplication, we'll get answer A. If we change the interest rate to 8.7%, that's going to be 0.087, or in other words, 87 thousandths. Multiply the principal times the rate times the time again, would get part B. And then finally, if we change the interest rate to 0.2036, so again, take that decimal point, move it 2 to the left because we're dividing by 100, then that'll give us that third interest amount. If she put all her tax money into a savings account, 5 years later, struck her home, she's got the tornado, she wanted to withdraw the money. Notice that each of these questions is only asking us how much money did she, oh wait, let me go back to this. How much money did she have? So these parts that I've worked out tell us the interest amount. The amount that she has is her original savings, so $3,450, and is that 23 cents added to the interest amount, and that's going to give us her total. So when we make the final answer, how much money did she have? We'll add the interest to her savings amount. Let's look at the third question. Jennifer is trying to decide which account would earn her the most interest. She intends to put her inheritance, $35,098.78, in an account for 7.5 years. This is a good opportunity for you to stop if you haven't already done so and just take a guess. Which of these three, 9%, 8.75%, or 8.5%, seem like they're going to give her the highest return? Of course, just going for the percent, the interest rate, of course, the 9% loan pays the highest interest. But the catch is that 9% is compounded annually. What does that mean, compounded annually? That means that once a year, the bank assesses how much interest has been earned and adds that interest into the account. Now, if we've got something compounded quarterly, that means 4 times a year. Quarterly would mean that n, the number of times it's compounded, is 4. And the best is going to be compounding monthly. So that's 12 times a year. Or in other words, n, the number of times that's compounded in a year, is 12. What we're going to have to see is how much that drop in the interest rate. So we're losing, for part C and D, we're losing 1/4 of a percent, right, for the interest amount, but we're getting that interest added into the account more often. So when we apply this formula to each of these three cases, you could see which one turns up the highest return. But before you do the math, make sure you make a guess. Think through which one you feel is going to be the highest, and then you can compare your results when you're done. Let's look at just one of these. Choice 1, the way we would apply the formula is that the amount, A, is going to equal the principal, $35,098.78, times the quantity of 1 plus 9%, or 9/100ths. And notice that although this formula, let me highlight where I'm at here with the formula. Notice that this formula says the interest rate divided by n. Well, since n, the number of compoundings in a year, is just once, the rate divided by n is just 0.09. And then let's look at what this NT is going to give us. That NT is going to tell us how many times over the course of the entire 7.5 years, how many times is that interest compounded. So how many times does the bank stop and assess how much interest you've earned and then add that interest to your account? So now you're making interest on the interest. So if the number of times we compound is annual, it's once a year, then how many times is it compounded altogether? 7.5 times total. So this formula would work. Now, let me give you just a little tip on how to put this in your calculator. What I would recommend is that you add the 1 to the 9/100ths mentally, because it's simply 1.09, and then raise that 1.09, raise that, so you, in most scientific calculators, could use this caret key. We call this a caret button. So 1.09 caret 7.5. And then once we've raised that piece to the exponent, and watch what, do you see what I'm doing? I'm applying the order of operations. I'm doing what's inside the grouping symbol first, 1 plus 9/100ths. And then I'm doing the exponent raised to the 7.5. And then I'm going to go back and multiply by the $35,098.78. try that on your calculator and see what you get, and then we'll compare that to the next example. Now this next example, the calculator piece is going to be a little more involved. So let me walk through how I would recommend putting this into your calculator. Because this one's a little more involved here. You know, this adding, it doesn't matter when I'm going to do this adding, it doesn't matter if I do the 1 first or the fraction first. So I'm going to do that blue fraction first. This is what I'm going to put in my calculator. 0.0875 divided by 4, that's this, plus 1. And then I'm going to hit enter or equals. That gives me the sum of 1 added to that blue quotient, 0.0875 divided by 4. Then I'm going to use the caret key again, but I'm going to put in parentheses 4 times 7.5. Otherwise, what happens is the calculator is only going to raise that base, this 1 plus the blue quotient, it would only raise it to the 4th power. But by putting this in parentheses, 4 times 7.5, it'll raise it to that, it'll raise that base to that whole exponent. Now let's look at what is that 4 times 7.5 tell us. It means something's happening quarterly. It's happening 4 times a year. For 7.5 years, that's a total of 30, right? That's another way to do this, by the way, if you're not real comfortable with your calculator. You could do that 4 times 7.5 first, and then when we get to this part of the calculation, just type in the 30 itself. But doing the parenthesis 4 times 7.5 close parenthesis would work as well. And then the last step is going to be to say times $35,098.78. And then for this last one, it's the same, this choice 3, you do the calculation in the same way you did the calculation 2. So I'm going to leave that for you to do. Again, if you want, you could do this shortcut of saying, well, if something happens monthly, that's 12 times in a year. And if that's going for 7.5 years, that means the exponent is going to be 90. I hope that this short video has helped you with the process of working through these questions. Remember that you do need to upload your work and make sure it's a single PDF file with this file name, last name, first name, handout 4. And in addition to uploading your written work, you will need to type in your answers, and that way you know whether you're doing this correctly. And if you are getting the incorrect answers, you have a couple attempts, and the only attempt that goes in the gradebook is your best attempt. But take a couple attempts if you need to, and if you are still not sure how to get these answers, reach out to me or a math tutor so that you can get this taken care of and make sure that you understand the process before you move on. Thanks for the work you're doing, and let me know how I could assist you.